All right. This is lesson 7.3, understanding proportions. A proportion is an equation that states two ratios are equal. A proportion, okay, is two equal ratios. It's that simple. A proportion is two equal ratios. What that means is this. Do those two ratios form a proportion? Yes. Are they equal? Yes. Are the two ratios equal? If they are equal, then those two ratios form a proportion. That's exactly what it means. It's that simple. A proportion is two equal ratios. Part of this assignment is really simple in that they ask you to tell whether or not two ratios form a proportion. The first one would be something like this, 4 over 10 and 12 over 30. Here's the deal. There's two ways to figure out whether or not ratios form a proportion. One is to do this, is to go look here and go, okay, well that 10 became 30. How did the 10 become 30? Times it by 3. If this right here, if this is also the same by 3, then it forms a proportion, right? Do you see that? That means that they form a proportion. That's one way of doing this. There's actually three ways of doing this. So 4/10 and 12/30 does form a proportion. Another way of figuring out whether or not the two ratios form a proportion is to do something that takes more time. But what if you can't tell? What if I give you ugly numbers? And you're like, I don't have any idea whether or not, if I gave you one like this, 5/19 and, 417, 82,500, you know what I mean? Like all of a sudden, you have no idea, right? I mean, all of a sudden it's too much. When you get a problem like that, you aren't going to be able to tell whether or not that works. Another way of doing this is to watch what I do. You cross multiply. What is 10 times 12? 120. What is 4 times 30?
1. Yeah.
Guess what? If they're equal, they form a proportion. Remember how we already decided that 4/10 and 12/30 form a proportion? Well, notice when you cross multiply them, the numbers end up being equal. So then how could I figure out whether or not these guys here form a proportion or not? What could I do? Cross multiply, right? I could multiply these two together here and multiply these two together here and see if they are equal. If they're equal, they form a proportion. If they are not equal, they don't form a proportion. Another way of knowing another way of telling whether or not something forms a proportion, you ready? Is you reduce both of them. If when they are reduced, they're the exact same number, the exact same fraction, they form a proportion. If they do not, then they do not form a proportion. Let's look. Can 4/10 be reduced? Yeah. To what? 2. So you divide this by 2, divide this by 2. This becomes a 2, this becomes a 5. Can 12/30 be reduced? Yeah. So let's just do it by 3. It ends up being 4/10. Divide by 3, divide by 3. Oh, and then divide by 2, divide by 2. It's still 2/5. They reduce to the same fraction. Therefore, they form a proportion. That's the three ways you could figure out whether or not ratios form a proportion or not, right? Depending on which way it is, depending on the difficulty of the question, will determine which one of those methods you want to use. A lot of times you can look at this and go as 1/2 and 5/10. Does that form a proportion? Do you need to do anything? No. All you do is that 5/10. You automatically reduce 5/10 to 1/2, and you know that it forms a proportion. Right? Harder ones would be something like 13 sixtieths and 13 65ths and 2/10. So now this is the kind that you go, okay, all of a sudden, how do I know? Well, what method should you use if you aren't sure? If you go, okay, I don't feel like reducing those because 13 65ths, it doesn't look like it's reducible, but it might be. And you can't really tell. Well, first of all, does 10 become 65 easily? No. So that method doesn't work. So then what is the method that you would use, Jonathan? Cross multiply. What is 2 times 65?
30.
What is 13 times 10? Guess what, people? They form a proportion. They both, this guy over here can be divided by 13, and this can be divided by 13. That becomes a 1, that becomes a 5. Divide by 2, divide by 2, 1, 5. They're both 1/5. Does that make sense? So, you just have lots of different ways of doing it. Okay? You have lots of different ways of doing it. Let's see if they do any. Yeah, see, tomorrow we deal with the other aspects of this. You want to do a couple of samples of a question there?
Aren't they supposed to be ratios, not fractions?
Right. Yeah.
Can you times it? They're like 2 times 5 equals 10 and 13 times 5 equals 65. Maybe like that.
No. No. Try a couple. Let's do a few practice ones. Let's look at page 318. Do number, see if there's any difficult ones. Do number 7, 9. Do 7, 9, and 11. Read the directions. Yep. It's yes or no. Number 1 up here. 4 to 12 and 6 to 8. Do they form a proportion? What are some ways that I could use to solve this one? This is kind of an easy one. What could I do? Could cross multiply. 4 times 8 is 32. 12 times 6 is 72. Not even close. What else could I do that's really quick? Couldn't I reduce? Doesn't this reduce to 1/3 and this reduces to 3/4? Again, not the same. Right? When it reduces, they will reduce to the same if they form a proportion. So this is a big fat no. 9/11ths and 63/77ths. What can I do here? What method would you use to do this, Jonathan? Yeah, you go, how does the 11 become 77? Times 7. Is 9 times 7 63? Yeah. You know what that means? It means that if you were to reduce 63/77ths, you know what it reduces to?
Yeah, I did that.
Divide by 7, divide by 7. It ends up being the same. Does that make sense? Okay. What about the last one? 16/29ths and 16/27ths and 4/9ths. Does it form a proportion? No, why not? How does what did you do? How did you figure it out? Cross multiply. That's kind of long. These are numbers that you should be able to reduce, though. Maybe. Can you? Is this reducible? At the point that it takes you that long to be like, I'm not sure, you should do cross multiply. 16 times 9. What is 16 times 9? 144. And then 27 times 4.
Yeah.
Not even close, right? So does it form a proportion?
No.
How many of you got all 3? Okay. Your homework.